I put together a little video on slideshow on accumulators and how they can assist in boosting the flow rate in a domestic situation. It can also be assisted by the installation of a pump, but I'll deal with that separately later on. What I've taken for here is a standard utility water main, taking it at say 4 bar. Now that pressure will vary throughout the day. Probably be best at middle of the night when the pressure is the highest. But anyway, for the purpose of this exercise, I'm going to take it at being at 4 bar. And I have a 20 millimeter mains water running into the house, about 20 meters in length. Stopcock utility meter. Now there may be a non-return valve in the meter, but for the purpose of this we'll say that there isn't. There's a standard stopcock in the house, so we want to see how much the mains is going to give us under the conditions that we have. So we open the tap in the kitchen and we run it off, and we measure that we get 5 litres per minute into the kitchen sink. And under those conditions, the pressure here is 4 bar, and we get 0.5 of a bar at the kitchen sink or the stopcock, as near as we can get to it, right? We now have the system characteristics. We know we started at 4 bar and we finished at half a bar. So this is diagrammatic only, but normally the way the pressure will go in the system. So we start at 4 bar, we'll drop down and we'll have a bigger drop through the stopcock and the meter. Again, it'll drop off fairly steadily and evenly through the pipe, through friction loss. We'll have another drop here, and then we'll get to the tap and we'll have 0.5 of a bar left. And this will be discharged through the little nozzles in the tap. The no flow condition, which is that there's nothing flowing, is obviously you're going to get 4 bar at the tap until such time as you open the tap, and then it'll drop off or follow that. The legend I will be using in the next few slides are as follows: a pressure gauge, a pressure reduction valve, an isolation valve, a non-return valve, a pump, and a 100 litre nominal accumulator. Now, accumulator is basically a steel tank with a membrane that is compressed with some air, and under normal conditions when the vessel is empty, the membrane may follow the profile of the accumulator. Not always. It can take up some of the space. Okay, so what we want to do is we want to boost the mains. We need 11 litres per minute in the house, and we need it at 1.5 bar. So at 1.5 bar, what can the mains give us at 1.5 bar? So we throttle back here or at the tap until we get the pressure here up to 1.5 bar. That's actually shown better on the next one. So we get that pressure up to 1.5 bar. We now know the pressure that we want. We have the flow rate and the pressure of the system from the first test. So substituting those figures, that, and the delta P into this formula here, we can get the velocity to give us 4 litres at the outlet here. I'll go through that again. have 3.5 bar under the normal condition when the tap is open. We throttle back in order to get 1.5 bar at the tap. But that gives us 2.5 bar of a drop. Using that formula then, we can calculate that this is roughly the profile that we're going to get. Now, we require 8 litres per minute at 1.5 bar. So we know that the mains can now deliver 4.3 litres per minute at the 1.5 bar. So the accumulator that we're looking for has to do 3.7 litres per minute at 1.5 bar. So we fit the accumulator. We put a non-return valve here. If there isn't one in the meter, you're better off putting one there. Forget about the pump for a minute. We'll go into the accumulator, back out through a pressure reduction valve, and into the system. And we have a non-return valve here, just in case the mains pressure during the daytime drops below the charge pressure that we have from the night, which is 4 bar. So we're after charging this during the night time up to 4 bar, and we have 100 litres of water in it. So we now have this profile that we know that the mains water is going to give us, or the main is going to give us 4.3 litres a minute at 1.5 bar, and the accumulator will give us 3.7 litres per minute at 1.5 bar. So if we set this at 1.5 bar, this pressure reduction valve here, we're going to maintain the pressure in that at 1.5 bar, which is going to mean equal the mains pressure coming in. So now we've got our 3.7 litres per minute and our 4.3, which gives us 8 litres per minute at 1.5 bar. Now you can also boost it higher than that if you put a pump in and charge the accumulator above the mains pressure, but then you won't get any assistance from the mains, so you're relying completely on the accumulator and what's available from it to discharge. Right, that's it.